In this chapter, we will be studying topics in trigonometry. In this lesson, we will be introducing the cosine law.
Okay, hi everybody. So now we're going to take a look at another trigonometric law here that we can use to work with triangles that are what we call oblique, that aren't right angle triangles. And this is the cosine law. Okay, and this is a really brief explanation here as to when you use it. Okay, you use this law when no given angle has an opposite given side. Now, think about this. We had a sine law, okay, and we've looked at that in a previous lesson here. You use the sine law when you've got like an angle A and a side A. When you have at least one pair like that, it might even be B and little b or C and big C. But as long as you've got a pair like that, you can use the sine law. So when do you use the cosine law? Well, basically when you can't use the sine law. Okay, so the cosine law is used if you've got, for example, an angle. Let me use my pencil here. When you've got an angle, and then you've got the two sides that are adjacent to it. So you know the two sides together that make up that angle. You can use the cosine law to find the side opposite. And in that case, what you would do is you would use this version of the formula here. So little a squared would be equal to b squared plus c squared. Now, just think about that. Just take a look at that real quick. What do you see there? That's right. That's the Pythagorean theorem. So the cosine law is really just a little bit of a tweak of the Pythagorean theorem here. So a squared equals b squared plus c squared minus 2bc, and then the cosine of that angle. Now, that's not the only way that you can use the cosine law. Another situation where the cosine law will work is if instead of having an angle and the two sides adjacent to it, instead, what if you had just all three sides? Okay, if you've got all three sides, could you use the sine law? Well, no, because you need an angle and a side. But you can use this version right here of the cosine law to figure out the angle that you're missing here. So for example, if I wanted to know the angle A, okay, I can get, first of all, the cosine of that angle by going side B squared plus side C squared minus A. Now, and notice the connection there. When we're looking for angle A, it's going to be, we're going to subtract that little side A squared all over 2BC. Now, if, for example, if I wanted to find angle B, then it would be a squared plus c squared, and I would be subtracting little b squared over 2ac. That's how this pattern works here, okay? Now, bear in mind this is just the cosine of the angle. If you wanted to figure out what the actual angle is, you'd have to do, first of all, evaluate that and go second cosine or inverse cosine of this to get the angle. Okay, let's just take a look at some examples and see how this works. All right, in our first problem here, we're being asked to find side x to the nearest tenth. That's okay, I've got this angle here, 32 degrees. Okay, these two sides are next to it. I know this isn't a right angle triangle, I can tell by looking at it, so I can't use SOHCAHTOA here. And because I don't have an angle in the side opposite it, I don't have it. I'm looking for the side opposite, but I don't have it. I can't use the sine law. So I know in this case, and I can label these if I want. I could make this, for example, I can make this A, B, C. Then what I'm looking for is little a. And I know that this is going to be C, and then this is going to equal B here. So I can say here that A squared is going to equal B squared plus C squared minus 2BC cosine of A. So in this case, it's X squared is going to equal 12 squared plus 15 squared minus 2 times 12 times 15, okay, multiplied by the cosine of the angle A, 32 degrees. Now, I really want to push you all to do this in a way that will make your lives a little bit better, make it easier for you to get the correct answer. I watch students work with this a lot who will do this all in pieces. They'll do this, press enter, they'll do this, press enter, they'll multiply that, and they'll do this in pieces, and they consistently get it wrong when they do that, because if you do this first and then subtract that, and then multiply by the cosine of 32, which is what most of them do. Essentially what you've done is you've multiplied the cosine of 32 by all of this stuff in front. Even though when you look at the cosine law, the cosine of A is only being multiplied by these two terms here. So you don't want to do it like that. In fact, in order for me to get the x here, bear in mind that it's x squared, so the next thing I'm going to do here is I'm going to take the square root of this whole thing. I would recommend, to help you avoid any kind of order of operations mistake that could possibly pop up here, let's just enter this all into the calculator in one step here. Okay, so I'm going to make sure, first of all, I'm in degree mode, and I am. And so this will be the square root of 12 squared plus 15 squared minus 2 times 12, times 12 times 15, multiplied by the cosine of the angle in between 32. And when I press enter, I'm going to get 7.98. Now, did this say what to round it to? It's to the nearest tenth. So when I round it to the nearest tenth, it's going to be 8.0. So x is going to be approximately 8.0. If you choose to do this in steps because you feel that you've got more control over what's going on with the calculator when you do that, please make sure that you do this multiplication here, negative 2 times 12 times 15 times the cosine of 32. You do that all together. Don't leave off the cosine of 32 and do it for another step here. Please put those together. Okay? Unless you're really confident that you're doing it correctly, okay? Please try to do this all in one step. It's quicker anyway. That's probably a better way to do that. Okay, this next question says determine the length of side B to the nearest tenth. Okay, well we gotta look at the diagram here. Side B, this is what I want. Okay, let's zoom in just a little bit. Okay, it's nice that this is all labeled for me here. I know that this is going to be little a and this is going to be little c. Now, when I look at the formula that I've got way up here, I use this one to find A. But you know what? I can just switch how these things are labeled. I could make this, for example, I could make this B. And what that would do is I would just swap the B out for the A. I would just swap those two. So it becomes A squared plus C squared minus 2AC cosine of, and that becomes the angle B. Just going to swap them. That's easy enough. That's all it's asking me to do. So now when I come down to here, okay, I'm going to set up my equation here, my cosine law, to find B. It'll be B squared is equal to, and I wrote A squared plus C squared minus 2AC cosine of angle B. I know that for me to find B, the very last thing I'm going to do is take the square root. So it'll be the square root of A squared plus C squared minus 2AC cosine of angle B. Now I'm going to go get the pieces that I need. Well, I know that side A is 15, side C is 20, and the angle B here is 124. Okay, so let's plug that in. So that'll be the square root of 15 squared plus 20 squared minus 2 times 15 times 20 multiplied by the cosine of 124 degrees. And then I gotta make sure that my square root goes over the whole thing, because I want to make sure that I'm doing that part correctly. Okay, so now I'll let that kind of stay visible there, and I'll make this the square root of, just like I wrote, 15 squared plus 20 squared minus 2 times 15 times 20 multiplied by the cosine of 124. Close the brackets, press enter. And once again, it's asking me to go to the nearest tenth, so I'm going to round that up. I'll round that up to 31.0. So B is approximately equal to 31.0 units, whatever that happens to be. Okay, well, have a look at this one here. I don't know why the numbers turned out so large here, but anyway, you can't help but see them. Determine the measure of angle A to the nearest degree. Okay, so this one we're being asked to look at this a little bit differently. We're looking for the angle this time. So now I'm going to label this. And because this is angle A, I'm actually going to change that to capital A. We'll make that B. We'll make that C. So this is my little A. This is my little side B. This is going to be my side C. So when I go to my formula here, Oops, I'll go up and just show it to you first. Cosine of A is equal to b squared plus c squared minus a squared. I'm going to subtract the square of the side that's opposite the angle I'm looking for. And then I'm going to divide by the 2 times the product of the other two. So we come down here, and let's do that. So this will be the cosine of A will equal b squared plus c squared minus a squared over 2bc. So the cosine of A is going to equal b squared, okay, 19 squared, plus c squared, 9 squared, minus a squared, 16 squared, all over 2 times 19 times 9. Okay, so now, let's just go to my calculator. Let my calculator do that. Just make sure I can see that. Now, don't forget to put parentheses around the numerator. If you don't do that, you're going to get you're very likely going to get a number that the calculator won't know what to do with in our next step. So you've really got to make sure you get this entered in correctly. So 19 squared plus 9 squared minus 16 squared, close the brackets, divided by, open the brackets again, because I need to do this multiplication before the division. I needed to do the addition subtraction here before I do the division. Now I need to do this multiplication. So 2 times 19 times 9, close the brackets, and then I get this right here. Okay, so I've just seen that the cosine of A is equal to, let's make sure you can see that, 0.54385, and it goes on and on. Well, that's not what I was asking for. I'm asking for the angle. Oh yeah, but I can get the angle by doing the inverse cosine of that decimal. I know, I'm sorry, I'm going over the page number here, but anyway, whatever. So on my calculator, I will enter second cos, and I'm going to grab that answer. Okay, when you use the A and S in your calculator, so you're going to refer to the number that was just calculated, close brackets, press enter, and there we go. The angle that I'm looking for is 57 degrees. There you go. It's as easy as that. Okay, let's take a look at this next problem. I like this problem here. Find the smallest angle to the nearest tenth of a degree. Now, we don't want you to be the person who goes through and has to find every single one of these angles. In fact, let's label them A, B, C, because there is a way to determine this. And after playing with the sine law for a little bit, you kind of hope that you put this together, because there's a ratio between the sine of an angle and the side, the length of the side opposite it. Okay, and that ratio is constant. Part of that is because the side opposite the largest angle is the largest side. The side opposite the smallest angle is the smallest side. So when we look at this right here, let's think about this. We've got little c is 5, little a is 8, and little b is 11. Which of those three angles must be the smallest angle? Well, it's got to be C, because it's opposite the smallest side. This angle opens up to the smallest of the three sides. So now I am looking for angle C. And I hope that makes sense. And so this is going to be a squared plus b squared minus c squared. I know that this is the side. It's going to be opposite this angle, and it doesn't really matter about the other two. I can put those in whatever order I want, over 2ab. And now I will put in the pieces of information that I can see here. I see that a is equal to 8, so this is going to be 8 squared plus 11 squared minus 5 squared over 2 times 8 times 11. Okay? And so now we are going to plug this into our calculator. Now, my calculator battery died, so I got to use a little substitute here. So 8, whoops, sorry, I almost forgot. I almost did that wrong here. I got to put brackets around the numerator there. 8 squared, okay, plus 11 squared minus 5 squared divided by 2 times 8 times 11. And there's our cosine. Okay, that's what our cosine ratio is equal to. So the cosine of C is going to equal 0.9090, and that's going to go on and on forever. So angle C is going to be the inverse cosine of that. I'm going to let the calculator help me convert that into an angle here. So it'll be second cosine, to get the inverse cosine of that answer that I just got, that ratio that I just got. Oh, and I get to the nearest, oh, so now it says to the nearest tenth of a degree. I didn't see that, nearest tenth of a degree. I'm going to get 24.6 degrees. So C is approximately equal to 24.6 degrees. There you go. Now, if they had asked us for the size of the largest angle, we would have been looking for angle B, again, because that is opposite the largest side in this triangle. So if you'd never kind of thought about that before, I hope that sticks with you. All right, now, this question is saying determine the measure of angle B to the nearest degree. Now, I look over here, here's the information that I've got, but before I even get to that, if they're asking me for angle B, I know it's going to look like this. I know it's going to be the cosine of B is going to equal A squared plus C squared, and I'm going to subtract B squared all over 2A times C. I already know that. I don't have to put in a whole bunch of thought into that. I know that I'm going to subtract the side squared that's opposite the angle I'm looking for. Okay, so now I just got to go in and grab the pieces. So let's take a look here. So here's A. That's side A, there's C, so this is little c, and then this is going to be equal to B here. So it's going to be 11.6 squared plus, okay, 7.4 squared minus 15.2 squared. And that will all be over 2 multiplied by A multiplied by C. All right, now I'm going to go to my calculator to evaluate that. Maybe I'll put it over on this side. Whoops, forgot I have to log in. Oops, closed up on me. Here we go. Okay, so now this will be, in brackets, 11.6 squared plus 7.4 squared minus 15.2 squared, close the brackets, divided by open, 2 times 11.6 times 7.4. Close brackets, enter. Okay, so now we're getting this negative ratio here, and that's okay. That's okay. Don't worry at all about the fact that that's negative. That actually means something important to the calculator, okay? And so now I'm going to take the inverse cosine of that. B will be the inverse cosine of that particular value. And again, I need the negative there. Okay, that will probably be explained a little bit later. But we're going to do now the second cosine of that answer that I just figured out. Press enter. Oh, and notice I get 104. Now it says to the nearest degree, so 104 degrees. So B is going to be equal to approximately 104 degrees. You will see later on that the ratio here is negative, that cosine ratio is negative when the angle is greater than 90 degrees. As soon as it's between 90 and 180, that ratio would end up being negative. It's an interesting little relationship that exists there. Okay, so in this question, and it's going to be a little bit more involved, it says solve the triangle where triangle PQR has P equal 3, Q equal 5, and R equal to 5.2. It really helps to just draw this out. And don't worry about anything being to scale here. That really doesn't matter. You just need to have kind of a relative idea of how things are located with one another. So this is going to be 3, Q is going to be 5, and R was supposed to be 5.2. Okay, so we want to solve this triangle. Now in this case here, what that really means is just finding the angles. So what I would recommend you're going to do here, and we know, by the way, that we're going to use the cosine law because I don't have an angle side pair. I've only got the sides. So this can't be the sine law at this point. It's got to be the cosine law. And I would recommend, just because, okay, there is a possible issue that might pop up. I don't suspect it will for most of these questions here, but there is an issue here that might pop up. So I just suggest that you start with the largest angle. Let's find R. Okay, I know it's going to be the largest angle because little r is the largest side. So remember, this is little r, it's little p, that is little q. So here we go. We're going to find angle R here. So the cosine of R will be p squared plus q squared minus r squared over 2pq. Okay, I recognize the pattern, and again, I know that the little r is going to be the one that I subtract because it's opposite the angle that I'm looking for. So the cosine of r is going to be 5 squared. Whoops. Okay. Well, I got that backwards. I put the q there. Turns out it doesn't really matter here. So we'll put the 3 squared there, as long as the little r is in the right position. Order doesn't really matter for addition there anyway. So down here, I will put them in the correct order here. This is going to be 2 times 3 times 5. So the cosine of r is going to equal, I'll pull up the calculator. Okay, what's it going to be here? It's going to be, remember, put brackets there, so 5 squared plus 3 squared minus 5.2 squared. Close the brackets so that it does that part first. Divide, put brackets, 2 times 3 times 5, and again close the brackets because we want it to do that calculation and that calculation before it does the division. Oh, and we get actually a relatively nice little decimal there, 0.232. So R will be the inverse cosine of 0.232. Oops, can't see that. So here we go. Second cosine of that answer. Okay, we get 76.58, blah, blah, blah. So let's say 77 degrees. We'll round that. So angle R is equal to 77 degrees. Okay, so now I know this. Now, you could use the cosine law again to find another one of the sides here, or because now I have an angle and the side opposite it, well, now I could use the sine law. Okay, and maybe I'm going to use the sine law now to find the smallest angle, angle P. So I know, for example, I know little r over the sine of r, and I have little p, and I'm going to find the sine of angle P. So if I plug that all in, I know that little r is going to be 5.2. I know that angle R is 77 degrees, although when I do this on my calculator, I'm going to use that angle, that number right there. That is going to equal 3 over the sine of P. So now we'll do my cross multiplying here. 5.2 sine of P is equal to 3 sine of 77 degrees, and then I'll divide. So the sine of P will be 3 sine of 77 degrees over 5.2. Okay, so let's get that. So it's going to be, bring that over there, 3 multiplied by the sine of, and I want that answer right there, so I'm going to, second answer, divided by 5.2. Okay, so 0.5611, blah, 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 blah. So the sine of P is roughly equal to 0.5611, dot, 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 goes on and on forever. I want to know what P is, so P is going to be the inverse sine of 0.5611, dot, 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 dot. And I'm doing that because I'm going to use all of that. I'm going to do that right here. Second sine, second answer, and I get 34 degrees. So P is equal to 34 degrees. Now I could have easily used the cosine law here, but I want you to see that you've got some options here. And now, finally, Q, well, I'm not going to use either one of those to find Q. Okay, I know, and I'll clean this up here, I know that the sum of the angles has got to be 180. I know that R was 77, and I know that P here was 34. Q must be 69 degrees. And there we go. Now we've solved the triangle. Okay, I know all the angles and I know all the sides. All right, so in this question here it says triangle MPN has the angle P equal to 48 degrees, little m is 7, little n is 8. Find angle M. Okay, let's draw this one out. So this is going to be MPN. And what do we know here? We know that P is 48 degrees. Okay, that's easy. Little m is going to be over here. That's going to be 7. Don't know what little p is. That's fine. And little n is 8. Okay, so I'm being asked to find angle M. Awesome. Except for one little detail. If you look at what I've got here, I've got angle P and these two sides next to it. I can't use the sine law because I don't have an angle and the side opposite it. Got to use the cosine law. But given this scenario here, the cosine law is only going to give me P. Okay, so, whoops. I will be able to get P squared, and that's going to equal M squared plus N squared minus 2mn cosine of angle P. And I will plug that all in, but remember I'm going to end up taking the square root at the end, so I'm just going to put that in right away here. So M is going to be 7 squared, N is 8 squared minus 2 times M times N times the cosine of 48 degrees. And I'll just plug that into my calculator here. And we will get, make sure I can see all of that, so the square root of 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of 48. And again, just to remind you, I really do recommend that you do this all in one step. It does introduce the possibility that people do this in the wrong order if they try to do it in pieces here. Press enter, and I get roughly 6.2, okay? Roughly 6.2. Now, when I use that to find angle M here, I'm going to use this whole decimal. But for right now, just write down that 6.2. Now, I know this. So I could, at this point, do a couple of different things to get angle M. I could use the sine law, like I did in the previous question. Or, now I've got all three sides here, I could use the cosine law as well. And in fact, that's what I'm going to do this time. Okay, I'm going to do the cosine law because I did the sine law last time once we got to a situation like this. So I'm looking for angle M. So this is going to be the cosine of M will equal N squared plus P squared minus M squared, because remember that's what I'm looking for, and I know I keep saying that. I really want you to make that connection here so that you don't accidentally write this out incorrectly, over 2np. So the cosine of M, okay, is going to equal N, which will be 8 squared, plus P, which will be 6.2 squared, but I'm going to use that entire decimal that my calculator gave me, at least as much of it as it remembers, minus 7 squared, all over 2 times 8 times 6.2. So now I'm going to put that over to the side here. I'm going to pull out the calculator. And remember, we got to put parentheses around the numerator. So 8 squared plus answer squared. And I love the fact that the calculator will understand that. It will grab that number, put it there, and then square it. Minus 7 squared, close the brackets, divided by, open them again, 2 times 8 times, and again, I can put the answer there. And the calculator, again, will go back to that number that we just calculated. Press enter, and we get 0.5375 dot dot dot. Whoops, I'm pushing that right off the page there. So the cosine of M is going to equal 0.5375 dot dot dot, on and on forever. So M will be the inverse cosine of 0.5375 dot dot dot. And so here we go, finishing it off. Second cosine of that, whoops, sorry, I did the wrong thing. Second cosine of that answer, and we get 57 degrees. Now, I just noticed something here, and I want to warn people against doing this. Only round once. Okay, I know that I've had students that have looked at this and said, oh, look, that 8 forces that 4 up to a 5, and that 5 pushes that up to 58. No, 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 don't do that. We're going to round to the nearest degree here. Okay, going to round to the nearest degree, and we only look at that digit right there. So this is going to be 57 degrees. So M will be approximately 57 degrees. Whoops, way off to the side there. There you go. Anyway, I hope that makes sense. I hope that gives you a little bit of comfort with the cosine law.